All right, welcome to lesson 54, and today we're looking at rate problems, which as you pull up this video and you start it, you probably say this looks very similar to lesson 53 when we were dealing with ratios. And of course there's a commonality because we can use this similar idea of equivalent fractions to help us understand how a ratio and a rate and all of this really works together, right? And so we're going to use the same methodology this time to understand how to use a rate. And let's go ahead and get right into it. If you're not listening to me, it means you're trying to figure out what kind of car that is. All right, you got to take a minute and let's do a little math. If Mr. Gomez drives this car at an average speed of 55 miles per hour, how far will he drive in 3 hours? All right, so let's set this up. We're going to put some labels in. Instead of ratio, we're going to write the word rate here. What is our rate? And then, of course, we have, once again, actual. And this time we can put some labels on the side. We have an understanding that it's miles per hour. And we can put that down then. Right, there's our rate, 55 miles in 1 hour. And so the question is asking you how far is he going to go in 3 hours. And so we have this set up. We have two proportions that we can use. And so 55 over 1 is equal to, I'm going to put x over 3. So once again, we're going to look for the relationship. Can we see a direct connection across the two numbers that match up? If we can, that's going to make our steps hopefully easier or a little bit faster. If not, we're going to use cross multiplication. So if we do this, we can see that it is times 3. All right. So to figure that out, we want to multiply by 3 on the top. So 55 times 3 should get you an answer of 165. All right. I'm going to double check my work. All right. 3 goes into 16. 5 times 15, 1, 5, 15. All right, got it right. 165 miles in 3 hours. So we have example number 1. Go ahead and I've made the next one the sample. Let's do this one together too. It says if Mrs. Aikita's car averages 24 miles per gallon, then about how many gallons will she use on a trip of 300 miles? And so as we look at this, we can set it up in the same way. We have our rate, we have our actual, and then as we get this started, we're looking at miles per gallon this time. So we're going to do, I'm going to go ahead and put some abbreviations here, miles per gallon, and it says 24 miles for every 1 gallon. That's, I don't know if that's really good. Usually you want to get in the 30s and 40s for really good gas mileage. You should just be driving one of those super sporty cars or something like that. Anyway, how far does she actually go? Right, 300 miles, so how many gallons will she use? Hopefully her tank is large enough that she won't have to fill up too many times. To figure this out, once again, we're going to use this idea, looking for the relationship. Now here is where it gets a little trickier, right? Because as we look across, right, 24 to 300, we can see that it's not really an easy number, right? 300 is not very easily divisible by 24. However, we have that word about there, and about means that there can be some estimation there. And so from here, I'm going to transform 24 into the number 25 because I know that 25 works well with hundreds since 25 cents goes into a dollar, which is 100 cents. And so from that case, you still might not be able to determine the relationship, but it allows us to then set up our problem to possibly cross multiply and divide. And let's use that technique this time. So to cross multiply, I'm going to take 25 times our unknown of x, so that becomes 25x, and then 300 times 1, which of course is 300. So here's our new problem. 25 times what equals 300? And to solve that problem, of course, you're going to take 300 and divide by 25. So 25 goes into 30 one time. And we get a 50 there. 25 goes in 50 two times. And so in the end, she's going to need to have about, right? We still want to keep that word in there, about, because we rounded at this point. So we have to have that answer in there. All right. The other thing you could have done is you could have left this at 24. And as you would have worked through this, you would have ended up coming away with a decimal of some kind as you were working with this response. Probably 11 point something. Right? But in the end, we have that idea. All right? So rounding before or rounding after, technique that you can use when looking at this. All right? Should we do it? Should we do it with a 24? All right, so that would have been, come away with 24x equals 300. So 300, 24, I gotta know. All right, now that puts me at 60. Let's extend it. 60, 24, that's gonna go in 2 times. That's gonna be a 48. And now, that's not right. That is right. But that's not right. This is right. No, what am I doing wrong? Pause the video. Unpause the video. I was second guessing myself. I shouldn't have done that. I was right. Okay, in the end we're going to come away with an answer of 12.5, which might better round to 13, right, as we look at that. So both techniques are going to get us to different answers, right? If I round before, I only get about 12 gallons, but if I round after, I get 13 gallons. So which one is the better answer? Think about it. Would you rather have a little more gas or not quite enough gas? Here's your sample then. Go ahead and work through this step 1 and then step 2 as seen in the problem.